Today we're going to be looking at applying linear functions. So let's first take a look at the situation. A lumberyard sells pre-cut 6, 8, 10, and 12-foot beams for $1.20 per foot. So we write our function, y equals $1.20 times by x. So before we get doing this, we're going to create a graph, or a table, to show we bought a 6-foot beam that cost us $7.20, an 8-foot beam would cost us $9.60, 10-foot beam would cost us $12, and a 12-foot beam would cost us $12.40. So then, go to graph. Feet are my independent, cost is my dependent. So when I go to graph, 6, and right now, we're just going to connect them with a line, even though this is going to be discrete. So let's look at our next one. Suppose your family buys a movie card for a DVD store that entitles you to rent 25 movies. You rent 3 movies per week. So our equation is y equals a negative 3x because we are renting each. So we have a total of 25, but we're taking away 3 each week. So we know we're working with weeks and movies. Weeks is our independent variable. The number of movies we have to rent is our dependent. So let's go up by ones. And then for our movies, let's go by ones as well. 7, 8, 9, 10. Alright, so when we look, our y-intercept is at 25, so that means our y-intercept is up here at 25. And our slope is telling us we have a negative 3, so we go down 3 over 1. So I'm just going to keep following my slope down to see where I'm going to land. And plus I'll have a more accurate line if I keep using my same slope. So if we look, we can rent movies for 8 weeks before we run out of our 25. Alright, so look at the back side. In this situation, we have a helicopter takes off from the roof of a building, and the graph shows the altitude of the helicopter as it rises steadily for several minutes. So what does the slope and y-intercept reveal about the situation? Well, the slope reveals that if we start here, we're going up 100, and we're going over 2. So we have a slope of 100 over 2, which actually equals 50. So our slope is telling us that we are rising 50 feet every minute. And then our y-intercept, which is at this positive 200, tells us that the helicopter is on a building, which is 200 feet tall. So we want to write an appropriate equation. So y equals, we know our slope is we are rising 50 feet every minute, and we are starting at a height of 200 feet. So for a similar situation, if the slope is 85, that means that the helicopter is rising 85 feet per minute. And if our y-intercept is at 250, it means the helicopter is on a building that is 250 feet tall. Alright, for our fourth situation, the graph at the right models the height in inches of a burning candle as a function of time and hours. And does every point on the line represent a value? So yes, it does, because when we are burning a candle, it's actually hitting all these points because the candle is gradually burning, and the same with our time. So yes, because all real numbers are used. So we want to write linear functions. Y equals, well, we know our slope is we're going down 2 over 1, so we have a slope of negative 2x, and we are starting at a positive 8. So if a second candle burns at a rate of 3 inches per hour, how would the graph for that candle compare? The second candle will burn faster because it's losing 3 inches each hour instead of 2.